Hi, I'm Jim Harris, an international best-selling author on disruptive innovation, and we're experiencing a lot of disruption these days. How can industrial AI help us gain insight? I'm here talking with Heiko Claussen, who is the Senior Vice President of AspenTech, who is an industrial AI data scientist. And we're going to have an interesting discussion here. So Heiko, the second topic that maybe we should focus on is intelligent business. And it occurs to me that most industrial processes are blind to what's happening inside the process. And as we have IoT, which is Internet of Things sensors, and we have 12.3 billion IoT sensors right now in 2022, and that's going to go to 30 billion. So this huge proliferation of sensors that we can get insight into what's happening inside vats, inside pipelines, inside manufacturing processes. Temperature, flow rates, chemical composition. We can measure for an infinite number of variables, capture this data, analyze it in real time, and predict if we're going to have a problem. For instance, predictive maintenance is able to send 10% of maintenance budgets simply by saying, this part is going to wear down, let's change it out before it breaks and stops the line. So what are your insights around IoT as a trend and predictive maintenance?
So IoT is, as you mentioned, is like a very visible trend, and you also get more and more compute actually going to the edge because of that. Because originally people were mostly recording a lot of data in the hopes that it's going to be the oil of the future. And you basically attach some black box magic to it that's going to solve all your problems. But more and more people find that this is not true, and there's a lot of disadvantage of storing all data. Lots of processes are very hungry for data. If you have high-speed data acquisitions, if you have video type recording, you don't want to store this all.
So I just want to pause for 1 second and give I think of everything very simply. Like I have a camera at my front door that records, and I don't want to store 24 hours of data looking at the path to my front gate. What I want to do is just see when there's motion, when the Amazon delivery guy is bringing a package. So I don't need to really store 24 hours of video data, which is a huge amount of data. What I just need is motion detected recording for 20 seconds. And so one of the very important things I would be imagining is determining what is the data that is important to capture, to structure, and then to analyze.
Exactly. And that's what makes, in the end, AI go to the edge, to create this from this big data, smart data. And then you basically capture the smart data at different levels and make assessments out of that. Also, what is interesting is you mentioned that there's a lot of sensors, but in many applications, actually, you cannot sense at every location. Either you're disturbing the process, or it is infeasible to measure there because of temperatures or other aspects. And with AI, it is possible to combine knowledge from different sensors and infer the sensor as if it were there. So this is also an application that is very interesting in such an edge application.
I guess you'd call it a virtual sensor.
Exactly.
It's a predictive sensor.
Yes.
Very cool. Very cool. We talked, Internet of Things has really morphed into edge computing. So what we used to call IoT, we're now calling edge. And it's staggering to realize that 64% of the processing is now occurring at the edge, as opposed to in a data center, which is the center. So how is this architecture, IT architecture, changing the need for AI?
So you basically have AI on every level. You have it in the cloud, you have it in the data center, and it goes down to devices. Even inside of sensors, we have AI. And the goal is often to extract knowledge from, complex data, from streaming inaccessible data and transfer it as something that's easier digestible, either less data rate. You want to also on the lower levels, you want to have a high reaction speed, it's just a fast reaction to the process, while on the higher levels, you maybe do more consolidation, visualization, orchestration, deployment of models. So you train from information that you maybe captured over the overall fleet. In these scenarios, it's quite uncommon that a particular asset has an error. So if you find in, like, say, a pump, a particular type of error that you haven't seen, you can bring this up in a more central location and have the overall fleet of systems learn from that.
So this is taking learning from one particular situation, one particular pump that has an error code, and saying, can we take this learning and apply it to all pumps that we have in our either this location or all our locations?
Yes, exactly. So you basically have different use cases dependent on where your AI is sitting. And it's not that one solution fits all. It's really, adapted to the use case. And altogether, in this hybrid environment, that's where you create the most value. So it's not that edge is going to result in cloud going away or the other way around. It's really this collaboration of these different domains.
It's an and. And we've seen staggering growth in cloud. Cloud is huge, and we saw it grow 36% in 2021. And you work with the key cloud suppliers, so you're agnostic to cloud suppliers and are able to work with any of them.
Yes, we have partners. We partner with the main cloud suppliers, and that enables us to serve our customers in a broad and efficient way.
So I liked your term from big data to smart data, because we are awash in data. In fact, more data will be created in the next 2 years than all human history combined. That just blows me away. And so the issue is not about data. We have too much data, in fact. The issue is how to gather the relevant data, how to analyze it, how to create knowledge, and then the wisdom to act upon it. This is really the higher functions that we need.
Well, it depends. So it really depends on the use case. Many use cases actually are sparse on data. That's already what I mentioned before. I mean, you have very complex systems and they don't break always the same way. If you have millions parts, one part breaks in the one system, another breaks in another system. Often you have never seen such a failure at all, and you cannot assume that you first see all of that before you become operational. So many use cases actually have, on the AI side, have to address very little training data scenarios. So this is maybe a little bit counterintuitive where we're talking about big data, but really depends on the domain where you have a sparsity of data or where you have big data available.
Now, before we had AI, before we had IoT or edge, we had to just hypothesize, what is the root cause of this manufacturing line shutting down? And it took us often a long time to diagnose the problem, or we'd apply a solution that didn't address the underlying root cause. So, yes, we've been struggling with this for decades about unique situations we've never seen before. How is AI able to help us when there's no training data, when there's never been this precedent before? How is AI able to help us through that situation? Because just like human, the AI learning system has no experience with this.
Yeah. So it's a process basically that is continuously improving. So initially, if you have no information, you're basically just detecting abnormalities. So you basically train on normal behavior, and then you detect if something abnormal is happening. If you see something abnormal happening, you can try to find in the past similar events that were maybe not exactly, maybe they were not yet full failures, but there were similar conditions, and you can see maybe in the logs or other data, what was the cause, how was this addressed. And the more you run, the more assets you have worldwide that you are managing or working on, the more can you build this this knowledge over time. That really is a key element in a data strategy for a company.
There's one more concept I want to raise in this segment, which is called the Prius effect. I used to own a Prius. I just gave it to a friend. I'd had it for many, many years. But the Prius gives the driver real-time feedback on performance and it on fuel consumption, and it actually changes the driving behavior of the driver. So my wife says that I drove like a grandmother because I was wanting to conserve fuel, so I'd accelerate very slowly. So the electric hybrid engine kicked in more often, and I'd brake a long time before I needed to actually stop to reclaim all that energy. So the Prius effect is 5 to 15%. You can change performance, or in this case, fuel consumption, between 5 and 15% just by giving real-time data feedback on the performance of a system. What insights are you having on industrial processes when you help a client all of a sudden begin to see their performance in real time?
Yeah, so I mean, making it visible is a key element. So it's a first step, and we have a number of dashboarding solutions also for sustainability, emission dashboarding that enables you to really drill down on where these emissions are coming from, and you can focus on what you maybe even already in design want to improve. And then we also have solutions that are more on the real-time aspect, that are with the plant in the loop, automatically optimizing the efficiencies based on a particular cost function that you're creating. So if you want to drive down a CO2 emission, that can be part of your cost function. And then dependent on the actual behavior of your assets in the field, the algorithms are in the loop and, step by step, continuously improving this optimality.
So one more question, because it popped into my mind while we were just talking here. A colleague I know runs a biodynamic organic winery, and sustainability was very important to him. So he got LEED Platinum certified. And then some consultants came in and actually looked at the operations. And in the furnace room, they were able to reduce greenhouse gas emissions by a huge amount every year because of the way the equipment had been finely tuned. So there was a heating sensor and there was a cooling sensor, and they were on opposite sides of the room and improperly set. So the heat would come on and take the temperature up, and then the cooling would come on and take it back down. And they were in a continuous fight all year, wasting energy on both sides of this equation. So we can even have LEED gold, platinum certified buildings, but the operations haven't been finely tuned. Do you see cases like this out in manufacturing plants? In other words, hugely low-hanging fruit that when a new set of eyes is brought to bear on it, you can have huge payback, huge savings.
So I think this really shows that it's important to look at it from different angles. So you have to look at it in the design space as well as in the operational space, on the maintenance space. In the end, the overall picture is, if you're blind on one of the eyes, you can have a huge loss somewhere. So you really, need a solution where all these things nicely work together and enrich overall your performance.
Some of the case studies that are interesting from AspenTech involve higher production rates with no CapEx. In other words, no additional capital spending. So if we really don't understand intimately from the inside of our equipment how things are operating, we're just blind. However, if we do understand that, we could perhaps increase the throughput of the machinery by 10, 15, 20, 25% without threatening the capital. In other words, without eroding the machinery, without threatening the viability of this very capital intensive equipment. And when we started and talked about the pharmaceutical companies needing to ramp up vaccine production, for instance, to face this unprecedented crisis globally of COVID. Have you seen this as a trend? Because capital intensive industries are very CapEx sensitive. So can you comment on this?
Yeah, so it's actually a key differentiator that we have. And the key differentiation is our expertise on first principles and the addition of the data-driven technologies as a part of that. So with the first principles, we can ensure that the asset is running safely and in a theoretical optimum. And with the data-driven, we can enrich it based on maybe aging aspects and other things that are not modeled. So altogether, this allows us to be on the one side more flexible because we can operate in regimes of operation that we have never seen before and guardrails by the first principles. And on the other side, we can really leverage the data and attune to the particular asset that the customer has. So it's basically a custom fit operation, a one-off for that particular device, which really drives this operation to its optimal.
So when I was in Rome in 2016, with the launch of a high-speed train with Trenitalia, where the company had put 1,000 internet's IoT sensors on the train at different points to measure wear and tear and when a part was about to fail. Historically, what we've done with maintenance is say, the mechanism to open and close the train doors needs to be changed every 3 years. And we change all of them at 3 years. However, the doors that are right by the stairs that come down get opened the most, and they might wear out after 2 years. And the ones at the far end of the platform that never get opened, they'll be good for 7 years. And so if we have a 3-year maintenance program where we change all the mechanisms every 3 years, we're having breakdowns with these ones 1 year in advance. And those ones we change out when they still have 4 good years left on them. So predictive maintenance is able to, number one, cut costs by 10%. And for Trenitalia, it was a 1.4 billion euro budget. So 140 million euro a year. 2, we get increased reliability, more uptime, which is increasing customer satisfaction. So it's a huge win-win-win. Lower cost, better performance, higher customer satisfaction. So what is your experience with predictive maintenance? So let's just frame it. How is predictive maintenance cutting cost, improving quality, decreasing downtime?
Yeah, so you already mentioned a good point. So there are a lot of use cases where it's really effective to schedule your downtime in a more smarter way. So we have, for example, customers in the wind energy for wind farms. Yeah, there, if a particular wind farm is slowly experiencing some wear, you might want to rather lower the way you're operating it, the stress on this particular windmill, so that you can time the repair in a more effective way, so that you don't have to put a crane into the field. You don't have to send people there all the time or for every instance, but you can bundle these and in this way become much more efficient. So there are lots of angles that predictive maintenance can help you to optimize costs, efficiency, and also safety of the devices. If you're in the assets, high cost asset space, you have a refinery, you can't afford that to all shut down. So there's maybe a slightly different strategy that you have to run. But again, to have this inside knowledge on the quality and how far the process is from a repair needed and how critical that particular asset is for that process, that really informs your strategy to make sure that you don't have wastes from a shutdown of an unplanned event.
Now, this example I cited from Trenitalia had a 10% saving on a 1.4 billion euro budget. 10%. It was framed as 8 to 10%. What typically is the cost saving that you see from preventative maintenance?
It's a difficult question because it's very dependent on the use case. I mean, you can imagine, you can calculate that easily by if you have to bring a maintenance crew out onto an offshore wind farm. You know, there's a lot of costs involved with doing one trip. So this is basically you save a set number of trips to do that. If you are have to shut down a reactor or a big plant, just by starting it up again, you can create a lot of waste through a flare and getting that process tuned again, everything running again. This is all basically what you can save if you time this right. But every operation has a totally different value to this process or to this